So now in this video, we're going to look at a circuit using a P-channel enhancement mode MOSFET right there. So we're using the BS250. That's the transistor right there. It does not depend on current for whether it is on or off. Right now, the LED is on. It could be in either state right now. The jumper is floating. You can see with my finger, I can change whether it's on or off. And it was turning off easier before. There we go. I was able to get off. But in any case, if you definitely want it off, you go to the positive supply right there. It is off, as I showed on the schematic there. If I switch it to the negative supply right there, I was going to say on, but it's the negative supply which will turn the transistor on. That's what that labeling means. There you can see. Or if it was already glowing, you know, it'll stay glowing. It'll be probably more on right there. But any case, we have a MOSFET transistor there. It's P-channel though. It is enhancement mode. So we will zoom in, and the schematic symbol that I have there for the P-channel enhancement mode MOSFET. I got the part number there. I'm using the BS250. I did not get ones that were in the TO92 package. That's the more common view for other transistors right there. All kinds of transistors come in this TO92 package, and you know, they may be available, but generally you don't see the E-line package right there. But again, it has 3 pins. The front is the flat side right there. It actually gets larger on the back. We'll get to that. But left pin is drain, middle pin is gate, right pin is source. So the source goes to the positive supply. If you know bipolar junction transistors, that's where the PNP, bipolar junction transistor emitter, goes. It's much the same, but the inner workings are a bit different. Then we have the gate. It is the control, and then the drain is where we got the load when we're using this as a switch right there. Going to the negative supply right there. I'm using a 220 ohm resistor and a red LED because I got 5 volts right there. Red LED will get pretty bright. Now, the gate doesn't let current in or out. So you see a gap there. It's kind of like a capacitor, which is, basically how this part, the gate, works right there. So you put it to the positive supply. That makes the gate more positive. The other side right there, the channel, becomes more negative right there. And that is why it is off, because this is an enhancement right there. So the channel becomes more negative, and then it's off. When we get to the negative supply right there, it makes the gate more negative, which makes the channel more positive. So that's where it comes into the P enhancement. The more positive you get the channel, the better it conducts right there. And so it makes a pretty good on and off switch right there. And that's generally how I see it being used. A weak input coming from like an integrated circuit output or something that can't power a load, in this case an LED, by itself, you just send the signal. You do got to remember that it's inverted though. So we got the positive supply up there. The switch is on the high side. When the gate is to the positive supply, then it's cut off. So it's not when the signal is positive, the load will be on. It's actually the opposite right there. That's going to hold it off. Whereas you got ground, that side's ground there. But you ground the gate. Remember, that makes the channel positive, and then the 5 can go through. So it's basically an inverted switch right there. And if that's a problem, you can re-invert it or whatever. But in any case, that is what we are working with. Now, this symbol that I use is the one that I like. I got it from the book, The Art of Electronics. I think that's the one they like the most too. There's all different kinds of MOSFET schematic symbols. And so you will see quite different ones. But hopefully there's a part number. Then you can just do a Google search of that part number and get all the specifications of this. And oh yeah. Also, this is important too. You saw I was able to use stray signals in the air, actually my body, to change what the state of the transistor was. And if you want to avoid that, you can use up a pull up or pull down resistor. I don't put that on the schematic of all of the circuits that I do. You don't really need one if you have a digital output, because it's either high or low. But as we saw before, we have this kind of, anywhere in between fully on and fully off right there. So here's a 10,000 ohm resistor. So if we want this to be off when we don't have a definite connection, then we can take the 10K resistor and put it to the positive supply right there, and then the gate. And oops, I went to the drain down there. All right, there we go. So yeah, now it's off. I don't think that plugged in great. Okay, it's off. Now we can get it on by putting the jumper to the negative supply. That's a direct connection right there. Doesn't matter right now that we have the resistor. There's a little bit of current being wasted through the resistor. But when I yank this, it's going to be off. It's going to stay off. My body can't get stray signals. Of course, we can put it to off there. So the pull down resistor will also work if your input is either off or to the negative supply. You know, you could do that as well. Sometimes not all outputs of stuff have both the negative supply and positive supply as their output, which is the input for this. Sometimes, you might either be connected to ground or off, which you can do with the mechanical switch. They commonly either connect to one supply rail, or they're just drifting in the air and off. So then you would definitely want either a pull up or pull down resistor. So that's pull up. In this case, that keeps the transistor off. Pull down keeps the transistor on. So be aware of that. Yeah, this E-line package, BS250 right there, I got from DigiKey. So I did not find one I wanted to buy on Amazon at the time. I think there are more options now. And maybe you can even get an TO92 package. But as I said before, the E-line package isn't all that much different than the regular transistor, other than the smaller side right there is the flat. And so that's the front, I mean. And the back is also flat right there. But it's wider, But the front is about, okay, I thought it was about the same size as the TO92. Looks like it is smaller. But then when you look at the back right there, you can see this is curved. So this isn't as wide in the back as it is in the front. Whereas the E-line package, that's TO92. The E-line package is wider in the back right there. And let's go over here. You can see the pin layout, drain, gate, source. So we want the source on top right there. So we can swivel this. Now we can see the source is up to the top. And then just kind of bend her down there. And then I can insert her into the board. So that's how we can make sure we got the right pin layout. Of course, always look at the data sheet. Definitely look at it for all the specifications and everything. But also the pin layout. I may make a mistake on my drawings. The data sheet is always the best source for getting information on the components that you can get. So now we got our pull down, but if we want to get it off, positive supply. That's the basic rules of using the P-channel enhancement mode MOSFET as a switch. Not all P-channel enhancement mode MOSFETs will have the same pin layout, of course. So if you're ever using a different part number, definitely don't assume it has the same pin layout. If it has a different different part number, good chance it has a different pin layout. Always be aware of that. Always check the data sheet by doing a Google search. So, in any case, that's really about it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.